Hey, what's up? It's Jake from Nimbus DevOps, and next we're going to be going over pods and nodes in a little bit more detail, and we're going to learn a little bit more about Kubernetes pods and nodes, and also how to troubleshoot a deployed application. So in my last video, we created a deployment, which we can see here, kube control get deployments, and I've got this Kubernetes bootcamp running. And what this also did is on my node, it created a pod, and in that pod is a container. So the pod is a Kubernetes abstraction that represents a group of one more app containers, like Docker containers, and then some shared resources for those containers. And that could be shared storage, like a volume. It could be networking, like with a unique cluster IP address, and any information about how to run each container, like the container image version or specific ports to use, stuff like that. A pod models the application specific logical hosts and can contain different app containers, which are relatively tightly coupled. So a pod might have both a container with your Node.js app as well as a different container that feeds data to be published by the Node.js web server. And the containers in a pod share an IP address, a port space, and they're basically co-located, co-scheduled, and run in a shared context on the same node, which is why we say they're tightly coupled. But pods are the atomic unit on the Kubernetes platform. What does that mean? That means it's the lowest level unit you're going to be working with in Kubernetes. So when we create a deployment on Kubernetes, the deployment creates pods and there's containers inside them as opposed to creating containers directly, which we did with Docker. So and each pod is tied to the node where it's scheduled and it remains there until it's terminated. And you'll have like a restart policy or something that tells it what to do with that, or if it's deleted. So in the case of a node failure, identical pods are scheduled um, on other available nodes in the cluster. So let me show you what this looks like. So here is a view of it. So here's one pod, and you can see the IP space in it. Last octet is .1, .2, .3, .4. And then in here it's pod, we have a containerized app, right? And then in .2, we have an etcd volume, some kind of storage volume, as well as a containerized app. And in here, I've got another volume, maybe the same volume, and I've got a containerized app, but I have this like smaller app. So this is like a totally different app. So maybe this is like we are saying, like your Node.js app, and then this is some kind of app that feeds data to the Node.js web server. And then in this one, I have two volumes and three completely different containers. So you can have a pod with its own IP space, but like um, all these objects that live in this pod are all tied to the same IP address. So that's what we mean by, I mean, they're very tightly coupled, right? So now let's scale back and talk about the node. So the pod always runs on the node, and the node is a worker machine in Kubernetes that can be either a virtual or physical machine, depending on the cluster. Um, like a virtual machine, like you run it in the cloud, physical, you run it in VMware, or you run it in well, I shouldn't say VMware could technically on VMs still be virtual, but then like if you did it on bare metal in a data center, or if you did it on a Raspberry Pi, that would be a physical. But each node is managed by the control plane, regardless of if it's virtual or physical. And the node can have multiple pods, and the Kubernetes control plane automatically handles scheduling the pods across the nodes in the cluster. So that automatic scheduling takes into account all the available resources on each node. So if you have a node that's got tons of stuff going on, and you need another pod, it might be like, well, this node's busy. I'm going to put this new pod on this other node, which is how the Kubernetes um, that process of scheduling figures out which node that your new pod should go on to keep resources allocated and how it can recover from failure. So that if you have a node go down, it can see, oh, their desired state is this many of each pod, and I had a node go down, so now I need to create new pods and I have to put them on new nodes. So something like that. So every node has the kubelet, which I talk about, and it's basically a process that's responsible for communicating between the Kubernetes control plane and the node, and it manages the pods and the containers running on the machine. And you'll have a container runtime like Docker that's responsible for pulling the container image from a registry, and then it'll unpack the container and then run that application. So let me show you kind of what that looks like. So get you a nice little picture here. So here is a picture of a node. And you can see we have this little kubelet running on here, right? That allows it to communicate with the control plane. And then we've got Docker running on here as their container service or container runtime. And then in here, we've got our same 4 pods that we showed you before. So we have a single node here with 4 pods running on it, and each pod is actually very unique. And we already talked about, what exactly all that was. So up to this point, we've used the command line interface for everything, and we're going to keep doing that. Um, and we'll get some information about deployed apps and the environments, and just show you a couple really common things like uh, the kubectl get to list your resources, describe to show detailed information about a resource, um, logs to get the logs from a container in a pod, and even exec, which allows you to execute commands on a pod. So let's check this out with a little bit of hands-on. So let's see, what do we want to do? Let's troubleshoot this Kubernetes app using the commands that I was just describing and see what we can see. So first things first, let's go get our pods. So I have a single pod. Okay, so we have our app running. We verified that, and then we have some pods running. If you don't have any pods running, it could be reloading from its previous state or whatever. Maybe just wait a couple seconds and then list it again. And then to view what's in there, so that was get pods, right? Remember I said we're going to get our pods. Now, what if we want some more information about this pod? Well, I can say kubectl describe pods. And in here, I can get a lot more information: the node IP, the labels, the actual IP, the container that's in there, the image ID, what port it might be exposing, et cetera, et cetera. And so that's using the describe command. And you know that pods are all in an isolated private network and you need a proxy to access them so you can debug and interact with them. So we're going to, again, split our terminal here, and we're going to start a proxy, kubectl proxy, and that's starting to serve. And then once that's running, we can get the pod name and query the pod directly through the proxy. So instead of using the Kubernetes API, we're gonna actually query this directly, and we'll do that with the curl command. So we want to get the pod name. So you've seen me do this before, but essentially what we're going to do is we're going to export the environment variable. I'll show you here. Pod name equals, and then basically inside of here, I'm going to create a variable, and I'm going to say, hey, get the pods, and in a template, and in the range items, pull the metadata and grab the name, and then make a new line and then end. So then I got that, and then once you do that, you can just echo this and make sure that it's correct. So name of pod is, and then yeah, that looks correct. So now what we can do with that is we can curl localhost and say on 8001, go API v1 namespace is the default namespace, go to the pods, grab this pod name, and then just go /proxy. And we want to curl this, and we can see, okay, we've got an API version, there's a failure, there's some sort of connection issue, whatever, and you can troubleshoot this by querying the proxy directly, which is kind of nice, right? We can also, if there's something wrong, and anything that the app would normally send to standard out, like on a Linux machine, becomes logs for the container in the pod, and you can get these logs with kubectl. So if I run kubectl logs, and then in this case, like I just want to look at my pod, so I'm going to do pod name because we already have it saved as an environment variable. I can get this and see, okay, this is what's in the logs that the application has outputted to our standard out file. So, and if there's something we wanted to do, like I wanted to get the environment, I could use exec command. So kubectl, and I want to execute a command on this pod, so I'll do $pod name, and then I just want the env, and then there's all my environment variables for that pod. So it's mentioning that the name of the container itself can be omitted since we only have one container, but in your work environment or whatever, you might have many pods and containers. So it's good to know how to do that. So you can also start a bash session. So instead of running env, I can just run bash, and you would have a console. Now something's wrong with my container, but you can do you can open a console like that. Let me see if I've got this. Oh, you know why? Because I need to interactive TTY. There we go. So now I'm actually in a console inside of my pod. All right. So there I am. The source code of the app should be in this server.js file. So if I cat this server.js, we can see, oh, hey, how's it going? If we cat this file, we can see that this is actually what's in the file. And we can check the application is up by running a curl command. So a lot of it is really curl. And if you wanted to do it I'm in the pod itself, I would just do curl localhost, right? There's no endpoint for that, like HTTP or anything like that. And I would just do it on port 8080. And we can see here, boom, and it's working. Gives me my pod name and my version, a little hello Kubernetes kind of thing. And if you want to get out of it, you simply just type exit, just like you would do with a user session. So there you go. That is essentially everything for Kubernetes pods, Kubernetes nodes, and a little bit about troubleshooting, enough to get you started at least. So if you have any questions, let me know. But if not, then good job. Keep going.